heat stress. And so what happens, basically you could think of this, what happens as we spend the summer in Indiana. So talking about maybe changes starting right about now to changes at the end of August, September, maybe even into October, as we've gone through the hot, humid summer. So here are the three outcomes for this one. So remember, acclimatization or acclimation is just the changes that occur in response to a stressor. So we call it acclimatization if it occurs in a natural environment. We call it acclimation if it occurs in an artificial environment. And yes, people do use artificial environments to train. So right before I got to University of Oregon, actually it was a few years before that, the Olympics were going to be held in Beijing. Beijing was very hot in August, or is very hot in August. And so people from Nike athletes would come on campus and use the environmental chamber to train to prepare for the kind of weather that they get in Beijing, because Pacific Northwest you can't beat in the spring and the summer. The weather is amazing. It's not always rainy, but it's very different than what those athletes would be experiencing when they went to Beijing. So how do we know if someone has started or is heat acclimated? And there's 5 main things. They're going to have a greater plasma volume, which this will lead to an increased stroke volume. And by having an increased stroke volume, it allows our heart rate to be lower than, to be reduced compared to what it would be in the heat. We become better at sweating, and ultimately we have a lower core temperature. Ultimately, the goal is to improve heat loss. We want to maximize how much heat we can lose during exercise. So, increased plasma volume. Basically, we're holding on to water. Well, how can we do this? And why do we want to do this? Well, we want to do this because we want to be able to maintain blood pressure. Blood pressure is super important because it lets us deliver oxygen and everything else that's in our bloodstream. So if we've got low blood pressure, it's going to make it very difficult to get blood throughout our body and get the oxygen and the nutrients where they need to go. Okay. Another benefit of holding on to more water is that we can sweat more. We have the ability to lose more water to sweat so to keep us cool. And so how do we hold on to water? Okay. And there's really one main driver, and that's plasma proteins. So albumin, for example, is the main plasma protein that allows us to hold on to fluid. So if I create or I produce more albumin, that makes it a lot easier to hold on to water in my bloodstream. Okay, and so as a result, I'll be able to maintain blood pressure, I'll be able to lose more water via sweat, that sort of thing. So, as we have talked several times throughout this semester, we want to be efficient. Well, having a high stroke volume and low heart rate allows us to be efficient, right? We're going to get more blood delivered per contraction of the heart. As a result, and the way that this is shown is our heart rate will be lower for a given intensity. And just to be clear, we're comparing exercise. We're talking about exercise in the heat. So we're talking about people. We're comparing people that are acclimated versus people that aren't acclimated. So people that are acclimated will have a lower heart rate for a given intensity. It will not be as low as their heart rate would be if they were exercising in a cool environment. I want to make that clear. So as a result, though, when you become acclimated, you'll hit your heart rate max at a higher intensity, and so your VO2 max will occur at a higher intensity, and it will be a higher value. Depending on the degree, I guess, of hotness, so how hot is it really, you will likely still have a VO2 max that's lower than what your VO2 max would be if you were in a cool environment. Okay? Now, you're going to become a better sweater, and there's actually 3 things that we can see from this figure here. And so notice on the x-axis we have core temperature, on the y-axis we have sweat rate. Okay? And so we've got heat acclimated in the blue line, and this orange-red line, we've got the non-heat acclimated. So there are 3 main things that are different. Okay? The first one is the onset of sweating occurs at a different temperature. People that are acclimated start sweating earlier. That allows them to stay cooler longer. Whereas people that are not acclimated, they'll start sweating at a higher temperature. Okay, so once you're acclimated, at least in this case, based on this figure, I'm basically saving myself or making it more difficult to go from 35.5 to 38 degrees Celsius. Now let's just say that your body has made the decision that if you hit 40 degrees Celsius, you're done. Okay, well, by starting earlier, it's going to take longer for me to hit that 40-degree temperature. Next is that sweat rates increased. Okay, so just look at, we increase our sweat rate to 2.5 liters per minute if we're acclimated, but we only increase it to a liter an hour. I think I said a minute, so 2.5 liters per hour compared to a liter per hour. Okay, I'm able to sweat a lot more, which will keep me cooler for longer. Okay, there's no time point on here. There's no time scale on here, so it might be hard to visualize. But if I'm sweating more, that means that there's more fluid available for evaporation. More evaporation occurs. That means I'll be able to stay cooler longer. And then finally, when I'm acclimated, I have a greater sensitivity to sweat. And so what I mean by this is that for a given temperature, I'm sweating more. Okay, so let's just take 38.5 degrees. Okay, so at 38.5 degrees, based on this figure, if I'm not acclimated, I'm sweating half a liter an hour. Whereas if I'm acclimated, I'm at 2.2, 2.3 liters of sweat per hour. Okay, and so for a given temperature, I'm going to sweat more. All right, I have a bigger response. I'm more sensitive to these changes in heat. And again, this is only possible if I've got an increased plasma volume. If I don't have an increased plasma volume, I can't get away with these changes. So as a result, I'm going to likely have a lower core temperature. And so there's debate as to whether having a critical core, there's debate as to whether or not 40 degrees Celsius is a critical temperature, meaning that if we get above 40 and stay there for a little while, bad things happen or not. But let's just assume that it is, okay? And so if we start sweating earlier, or if we have a lower core temperature, resting core temperature, we're going to have more time available to us, more time to exercise before we reach that critical core temperature. Okay, the last slide is just kind of want to show you how long some of these changes take. Okay, so after 4 to 7 days of exercise in the heat, your performance will increase. It takes about that long for your core temperature to decrease, your heart rate to decrease. The sweating response takes a little bit longer. And as you can see here, how long it takes, the decay is how long does it take for these changes to go away? Okay, so in other words, if you get out of the heat, it'll take you a couple weeks before you lose your gains for performance. Core temperature, you're going to have a decrease of about 2.5% per day, that sort of thing. Okay. So with that, we are going to end, and hopefully we have a good discussion in class about just exercise in the heat.